So that's why I opted to break the video into two videos. Maybe I'll post this as T and pi equivalent network. We got like 20 minutes to do a few examples on that. So when we're saying find the equivalent, so taking your transformer, taking a circuit that looks like this, something like this, and going, I don't want to deal with the effect of this on this plus going through this. When I get to this one, what's the current through it? What about the mutual inductance? I don't want to deal with that. Can I take this, replace it with something like this, or can I take this, replace it with something like that? And the answer is yes to both of these. So that's what T and pi equivalent means. So now if we take a circuit, we'll take just that one up there, just make it cleaner. Let's say we have L1 going through it. And we have a dot here. And we have I sub 1 going through this direction. I'll derive the equation for us. We have another inductor here. We'll make this L2. This is the dot. And let me make the current going through it I sub 2. And we have a mutual inductance between them. Just looking at that circuit, if you were to find, we'll call this V1 here. And I will call this V2. If I was to find V1, I go, well, let's not pay attention to this first. It's L1 times di1 dt. If I didn't have that piece here. But having that piece, there's a mutual inductance, di2 dt. And again, is it positive or negative? The current's entering this way is going to mark it what? Plus to minus. It's going to make this dot plus to minus. That's a positive. What about V2? Let's look at V2. Again, if this not here, it's going to be what? L2 times what? di2 dt. The mutual inductance di1 dt. Again, positive or negative. I sub 1 travels this way, plus to minus. The dot is plus, that's a plus. Good. Put this on hold for a second. Let it sit there. I'll bring it back later. Now let's say we have this circuit. And again, let me define the current. I sub 1 is going this way. And V1 is right here. I sub 2 is going this way. And V2 is right here. Let's call this value M. Let's call this value L1 minus M. And let's call this value L2 minus M. There's no mutual inductance here. I don't have to deal with mutual inductance. So I sub 1 is this current. And I sub 2 is this current, right? I define it going in. Let's find what V1, let's do KVL right here. V1 is going to be what? This inductor, L1 minus M times what? di1 dt. Keep going down. Plus, I'm going to travel down, M times the current down. What's the current down?
I1 minus I2.
d dt of which one? I1 minus or plus? Plus. leave a space there. Leave a space there. And let's, because there's a reason I'm leaving space. Let's go right halfway between them. Let's write an equation for this. What's V2 going to be? L2 minus M times that current, di2 dt, plus the mutual inductance of the current down ddt of I1 plus I sub 2. Everyone agrees with these two equations? No mutual inductance. Nothing. Now let's clean them. This becomes, distribute that, L1 di1 dt minus M di1 dt. Distribute that, plus M di1 dt plus M di2 dt. Are you sure? Chris already noticed that, you know what? That's the same equation as the one before. That's what we got before for V1. L1 di1 dt plus M di2 dt. Let's see what V2 is. Distribute that. That would be what? L2 di2 dt minus M di2 dt plus M di1 dt plus M di sub 2 dt. Cancel. And what do you have? L2 di2 dt plus M di1 dt. Is that the same equation from before? Yeah. So that tells me from now on, if I don't want to use mutual inductance, wait till you finish writing. From now on, again, this equation I derived was specifically good when I have this look. And I got I sub 1 going here, and I got I sub 2 going. So I sub 1 and I sub 2 both going to the dot. Notice they're both entering the dot. We just proven that we can take this one and replace it with L1 minus M, L2 minus M, and M, and this is V1. I sub 1 still entering, I sub 2 still entering. Now again, this is only good if the currents, both the currents enter in the dots. What happens if one of the currents not entering the dots? one was entering the other end. So if they're both entering the dots, that's correct. I don't care if the dots was here and the current enters. As long as both current enters the dot, that equation is correct. What happens if only one current enters the dot and the other one does not enter the dot? And I don't care where the dot is. You can put the dot anywhere you want to. So I sub 1 is entering the dot. You want the dot on the top? I can leave it on the top if you want it on the top. I just got to make my current enters this end. That will not be V2 here. That will not be the same equation. Why? Because the mutual inductance now, notice when I did this equation, the mutual inductance was a plus. So what's going to happen to mutual inductance here? This current is going to make a plus to minus. The dot will be minus, will be a minus here. Not a plus, will be a minus. So the equivalent of that will be this will be L1 plus M. This is L2 plus M. And this will be negative M. That's the equivalent.
Well, it makes sense because what if the dots were in like opposite coordinates?
Doesn't matter.
You do the current change.
As long as the current enters the dot, if both currents enter the dots, I don't care where the dots are, that's your equivalent. If one enters the dot, the other one does not enter the dot, that's your equivalent. So I could have took this dot here, Chris, and put it down here. As long as I make the current enters that dot, that's still the correct equation.
Okay.
If I make the current here and the dot down here, then it becomes that equation. So if both currents enter the dots, that's your equivalent. If one enters the dot, the other one, the other end of it, that's your equivalent.
Where do the currents go in that second equivalence?
Oh, this is same, that doesn't change. There's still I sub 1 here, and there's still I sub 2 here. Or you can make it coming out of it if you don't want to do it that way. Instead of going in, you can make it that way. So notice how both entering here. So one entering, one exiting. Now let's take an example and see if we can do that problem. If we can find one. See if I have another one here. What I could have done actually, the previous example. I could have done the previous example that way. And made my life much, much easier. Watch. Where was that problem? I mean, it's not that difficult really doing them. Where's that example? Remember this one? There we go. Remember this circuit, this problem? Let's do it with the equivalent circuit now. I'll just copy the circuit again. How are we doing on time?
You got 15 minutes.
Still? Good.
About 15 minutes. Still fine.
J3600. A lot of questions. What book do you use? The problem is, a lot of the problems is not really in any book. I just modify them. So it's not in a book there. I just, let's try this. and this is J1200. That was the previous example we did. My currents, I forgot to identify which direction my current's going in. I sub 1 is going where? Going to the dot. And what else? Where did we find I sub 2? I sub 2, I forgot to indicate where the dot is. We have it in the previous one. The dot was here. I sub 2 is leaving the dot. We had it going to the right? So I sub 2 is going this way, which means entering the other end of it. Make sure my notes stay in order there. So we have I sub 1 entering the dot, I sub 2 leaving the dot. So I can replace these two with what? With this circuit. Then I'll put the 200 after that. There's the 200. That's the J100. There's the 500. $300 angle 0. This is the 100. The 800. Negative J2500. I sub 2 is defined going this way. That's what I sub 2. So I'm not going to change it. I sub 1 is defined going this way. I sub 1. So what's the value? Notice I got one current entering the dots, one entering the other end. So the mutual inductance, I'm going to make it what? Negative 1200 J. And this one will be this value plus that one. 3612 is what? 4800. And this one here will be 16 plus 12, which is what? 28. And no more mutual inductance. So if you want to combine things just to make your life a little bit more manageable here, because that looks like a little bit ugly there. What's 500 and 200? And the inductors, you can combine them into one. J what? 4900. Negative 1200 J. $900. J 2800.
Which mean 300?
Which one?
Because the J and the capacitor.
Well, I was about to leave the capacitor by itself there. You know? But if you want to combine them, you can. I was about to leave it there. I could combine these into J300, yes. And probably be a smart move too. You know, instead of leaving two of them, why two? Just make it J300. Can I find I sub 1, I sub 2 now easier? We'll see if that gives me the same answer. So negative 300 angle 0 plus 700 I sub 1 plus j 4900 I sub 1 minus 1200 j, the current down I sub 1 minus I sub 2. No mutual, I don't have to look anywhere. Clean that just a little bit.
So this is the better way to do it, I would assume?
Well,
It depends.
if you don't like mutual inductance or not, you know, if you don't like plus, minus, let me think about it, you can do the equivalent there.
Okay. Just feel like it's a lot easier to screw up a sign, do it.
With the other one, yeah. So that's negative 1200 j plus 4900. What's 49 minus 1200? Is it 37? So 700 plus j 3700 I sub 1. That'll be plus 1200 j I sub 2 is equal to 300 angle 0.
Since that's a negative inductor in there, isn't that technically just a capacitor?
Well, value-wise, yep. Now let's look at this. We said combine these, that's 300, right? So I can say 900 plus j 300 times I sub 2. Now here's a negative 1200 j. What's the current going up? I sub 2 minus I sub 1. $1200 I sub 1 plus 900 minus 900 j I sub 2. These equations look familiar, don't they? Let's see, hopefully we didn't mess up a sign there.
We had a different sign on it.
Yeah, we had a minus sign. Let's see what happened here. Just to make sure I didn't screw up the sign. Negative 300 angle 0. 700 plus j 4900 times I sub 1 minus 1200 I sub 1 minus I sub 2. Second equation,
No, we should be fine because we just flip-flop them. Because the 1200J is backwards on both sides.
let's see what the value
I
there.
think it just flips the angle.
Well, it shouldn't be. Should give you the same one, but let's see. Quit. Simultaneous equations. Oh. Simultaneous equation. Let me app. I went to current, took me the one I don't want to. Current. New one. 2. So the first one I have 700 plus j 3700. Get that one. This is 1200J. And that's the answer, 300. This one, 1200J.
It's the same as the previous equation we had, except it's a positive 1200J.
900 minus 900J, we'll see. and 0, and solve it. Here's what I got. I sub 1 equals 0.063, angle what, negative 71.6 degrees, and I sub 2 equals 0.059 or 0.60, but the angle is different, negative 1116.6. So the first answer matches the second one, so we must have missed a sign somewhere. We must have missed a sign.
It's 180 degrees. So
Yeah, that means a minus sign. So it's minus m here, L1 plus m, L2 plus m. That should be there.
If you look at the differences between the two equations that we had,
Mhm.
the two problems, is the 1200J, whether it be I2 or I1,
Here?
are positive instead of negative.
Let's just look at the mutual inductance. We're doing this. Are they going the opposite direction? Maybe we wrote this one wrong. Let's see if it's plus minus. Did we do them?
No, you wrote the current wrong. No, when you showed us how this worked is both the currents went in.
Yep. Well, this one coming out. If they're both going in, this will be a plus. That'll be a minus. And that'll be a minus. That'll be L1 minus M. This is L2 minus M. I gotta check that. I'll check the other example on the other one. But that's what you do when they're both entering. We'll check and see if we made a mistake on the other one, mathematical, because
I think you made a mistake combining them because on mine I got the right angle.
when you combine them,
Yeah.
what do you
I
mean?
combined them all together to make like 700 plus J 4900, then 900 plus J 300 on both sides.
Yep.
And I got the right answer.
So then our math is wrong here. Combining. Let's see. That's J 3700 and 700. That's okay.
The first one just has a negative 1200. Is the only difference between that equation and the other one. From the previous one. Bring it up a little bit, okay.
Wait. The process is definitely correct. I'm just not sure if I missed a sign here or not, or on the previous one. So I'll leave this one, and I'll go back later and check the other one.